Hello everyone. Today we are going to discuss about the mechanism of elimination reactions. Elimination reaction is one with the substrate molecule loses two atoms or groups from the same carbon atom or from adjacent carbon atoms under the influence of an attacking reagent. So two atoms or groups are eliminated, okay, and if the two atoms or groups are eliminated from the same carbon atom, it is called 1-1 elimination. It is a rare reaction, and normally the most commonly observed elimination reaction is 1-2 elimination, in which two atoms or groups are removed from adjacent carbon atoms. So in this video, in this discussion, we'll be dealing only with the 1-2 elimination mechanisms. The most important example of 1-2 elimination is dehydrohalogenation, which means a hydrogen atom and a halogen atom are removed from adjacent carbon atoms. Here are some examples. If we take bromoethane and if we make it to react with a very strong base, such as alcoholic KOH, the elimination reaction takes place will be from this carbon, from the first carbon, bromine is eliminated, bromine is removed, and from second carbon, one hydrogen atom is removed to give ethylene molecule, plus this OH minus and this hydrogen will give you a water molecule, and a Br minus will be also a side product. Okay, so this is the simplest example for elimination, dehydrohalogenation. HX is eliminated. We can depict it like this: CH3, this is CH3, CH2, Br. Okay, this is bromoethane. Here two atoms and groups eliminated are one hydrogen and one halogen atom. That's why the name Dehydrohalogenation, which means that minus HX. HX is eliminated from the substrate molecule. Okay, hope it is clear. Now let's see the second example, 2-bromopropane. If we take 2-bromopropane and if we react it with alcoholic KOH, you'll be getting propene. That is from first, second and third. If we name it, if we number it like this, Br is eliminated from second carbon atom and one hydrogen is eliminated from any of the first or three, because they are identical. So it can be, the hydrogen can be abstracted from any of these carbon atoms to give you propene as the elimination product. And this is the tertiary butyl bromide. Tertiary butyl bromide, when made to react with alcoholic sodium methoxide, it's in fact a stronger base, and you'll be getting 2-methylpropane as the major product. Here also this bromine is eliminated from this carbon and all these three carbon atoms are identical. So from any of these methyl groups, one hydrogen is also eliminated, so that there is a double bond is formed between these two carbon atoms. Okay, these are the examples for dehydrohalogenation. Here we have discussed the dehydrohalogenation of a primary, secondary and tertiary alkyl halide. All of them are proceeding with a similar mechanism and you are getting expected products. And now the already discussed three substrates were actually, there were no confusion regarding the position of the double bond, but here if a confusion arises or if we have to select between any of the two neighboring positions, what shall we do? That is governed by Zaitsev rule. Okay, orientation and reactivity in elimination reaction is governed by Zaitsev rule. It states that in a 1-2 elimination reaction, the predominant product is the most highly substituted alkene. That is, the one has the greater number of alkyl groups attached to a doubly bonded carbon atom. Okay, here the problem is, I'll depict it. Here, the 2-bromobutane is CH3, CH2, CH, Br and CH3. Right. So, I'll be writing this one with two different colors. Okay. So, this is one hydrogen possible and this is the second hydrogen available. And you can understand that these two hydrogens are not identical. In the previous examples, all the other alkyl groups were identical. So from hydrogen could be eliminated from any of those carbon atoms, so that only one product is obtained. Here, suppose if the if the elimination takes place from these two carbon atoms, the product will be but2ene. That means the double bond is obtained. The double bond is formed between second and third carbon atom, right? And conversely, if the elimination takes place like this, you will be ending up with 1-butene, okay? And from the data given, we understood that elimination takes place to form but2ene. 2-butene is the major product, okay? Which means that elimination has taken place like this. Okay, so that a double bond is formed between second and third carbon atom. Okay, അപ്പോൾ ഇതാണ് major product എന്ന് പറയാൻ വേണ്ടി നമുക്ക് മെക്കാനിസത്തിലേക്ക് പോവാണ്ട് തന്നെ നമുക്ക് പറയാൻ പറ്റും എങ്ങനെയാണ് based on Zaitsev rule. Zaitsev rule പറയുന്നത് എന്താ? ഇവിടെ carbon carbon double bond C. In the case of 2-butene എന്ത് ചെയ്യുന്നുണ്ട്? Carbon carbon double bond substitution എന്ന് പറയുന്നത് 1 methyl group, 1 hydrogen. Here also 1 methyl group and 1 hydrogen. Appo 2 alkyl substitution ഉണ്ട്. Around C double bond C, there are 2 alkyl substitutions. Okay, but here in the case of 1-butene, C double bond C എടുക്കുന്നു. On 1 carbon, both are hydrogens, and here again 1 is hydrogen. ഈ രണ്ട് carbon atom, ഈ രണ്ട് hydrogen atoms ആണ് ഇവിടെ കാണിച്ചിരിക്കുന്നത്. ഇവിടെ നോക്കുക, ഒരു hydrogen ഉണ്ട്, പിന്നെ ഒരു alkyl group. Okay, ഇതാ ഈ ഒരു alkyl group. അപ്പോൾ substitution ഇവിടെ എത്രയേ ഉള്ളൂ? Just one. In the case of 1-butene, there is only one alkyl substitution, but in the case of 2-butene, there are 2 alkyl substitutions around carbon-carbon double bond. So 2-butene is the major product. Okay. Okay. Now we have to explain why is it so. The answer lies in the number of hyperconjugative structures. We have already studied hyperconjugation and its applications, and here we know that as the number of hyperconjugative structure increases, the stability of alkene increases. Number of either structure ne hyperconjugative structures കൂടുന്നതിനനുസരിച്ച് ആ particular structure ne stability കൂടും. Here നമ്മൾ നോക്കുക, this is 2-butene. This is 2-butene. Here, I'll write only one the first hyperconjugative structures. Okay, to give you CH2 plus CH, single bond C minus H, CH3. Okay, this is one structure, and from here there are 2 more hydrogens which can perform this one. So 3 from this side and 3 from this side. So altogether there are 6 hyperconjugative structures. But in the case of 1-butene, this is 1-butene. This is 1-butene. Here the number of hyperconjugative structures is only 3, because only 3 hydrogen atoms are attached to this carbon. Okay, so that is the reason why 2-butene is more stable than 1-butene. Now let's see 2 more examples from which the Zaitsev rule can be explained very much easily, can be understood easily. Here, in the case of 2-bromo-2-methylbutane, I'll write it here, CH3, CH2, CBr, CH3 and CH3. Okay, so here also we can write 2 positions instead of this. Okay, it's a CH2 now. Okay, this is not CH3, this is CH2 now. Now see, if the bond is eliminated, if the HBr is eliminated, the HBr is eliminated like this, okay, like this, you will be ending up with this minor product, okay, only a few percentage of this product will be formed. And if the elimination takes place like this, you will be ending up with this one. This is the major product, 2-methyl 2-butane. This is just because we don't have to see the mechanism and all. We can just simply look at the structure, look at the we can write two possible structures, and by looking at the groups attached to the carbon-carbon double bond, we can come to a conclusion. Here around carbon-carbon double bond there are 1, 2 and 3 alkyl substitutions, and in the case of, and that's why this is the major product. In the case of this one, there are only here 2 hydrogens and there are only actually 2 alkyl substituents, okay, one methyl group and one ethyl group. Okay, now it is clear, I think. And we can see another example in which 2-bromopentane is undergoing elimination reaction to give 2-pentene as the major product and 1-pentene as the minor product, because in here also around carbon-carbon double bond there is, in the case of 2-pentene there are there are 2 alkyl groups attached, okay, 1 methyl group and 1 ethyl groups are attached around C double bond C in the case of 2-pentene, whereas in the case of 1-pentene only 1 alkyl group, it's the larger group, but still there is only 1 alkyl group attached to carbon-carbon double bond. That's why 2-pentene is the major product. Now we have to see, till now we have discussed about elimination reactions and different types, the Zaitsev rule and all. Now we have to see the mechanism, how actually elimination reactions are taking place, okay. Just like nucleophilic substitution reaction, here also there are 2 types of mechanism which is similar to that of substitution reaction, like the analogy is the same. Here E1 and E2 reaction, just like SN1 and SN2. In the case of E2 reaction, it's of second order, okay, that we have seen in the case of substitutions and all, substitution reactions already. It is a second order reaction in which which means that in the rate equation both the substrate and nucleophile are present and the order is 1 + 1 2, okay. The rate is proportional to the concentration of both the substrate and the attacking base. The rate is proportional to the concentration of both the substrate and the attacking base. Okay, the best example is the dehydrohalogenation of ethyl bromide. Okay, primary alkyl halides. This is an example of a primary alkyl halide. Primary alkyl halides generally undergo elimination only by E2 mechanism. Okay, primary halides undergo E2 reaction only by, they undergo elimination reaction only by E2 mechanism. Here bromoethane reacts to give ethylene, water and Br- as the byproduct. This is the classical example for E2 mechanism, E2 reaction. This is the mechanism. This is the mechanism. It is clearly shown here. Like first this base abstracts 1 proton. Okay, proton adjacent to carbon bearing the halogen. Okay, this Br and this hydrogen have to be eliminated. Okay, this Br and this hydrogen have to be eliminated. So the base attacks the hydrogen first, and then it forms a bond with hydrogen. And നമ്മൾ നേരത്തെ SN2 പറഞ്ഞിട്ടുണ്ടായിരുന്നു, എത്ര കാർബൺ ന്യൂക്ലിയോഫൈൽ ബോണ്ട് ഉണ്ടാവും അത്രയും കാർബൺ ലീവിംഗ് ഗ്രൂപ്പ് ബോണ്ട് ബ്രേക്ക് ചെയ്യും. അതേപോലെ COH ബോണ്ട് സ്ലൈറ്റ്ലി ഫോം ചെയ്യാൻ തുടങ്ങുന്നു. ഇത് സ്ലൈറ്റ്ലി ഫോം ചെയ്യുന്നതോറും എന്ത് ചെയ്യുന്നു, ഈ ഹൈഡ്രജനും ഈ കാർബണും തമ്മിലെ ബോണ്ട് എന്താവുന്നു, ഇറ്റ് ഗെറ്റ്സ് വീക്കെൻഡ്. ഓക്കെ, ഇതൊരു ഫുൾ ലൈൻ ആയിരുന്നു, സോളിഡ് ലൈൻ ആയിരുന്നു, അതിപ്പോ എന്തായി, വീക്കെൻഡ് ആയി, ഡാഷിൽ കൊടുത്തു. ഇത് എത്രത്തോളം വീക്കെൻഡ് ചെയ്യുന്നോ അത്രത്തോളം എന്ത് ചെയ്യും, സി സിംഗിൾ ബോണ്ടിലത് ഡബിൾ ബോണ്ട് ആയിക്കൊണ്ടിരിക്കും. ഓക്കെ, ഡബിൾ ബോണ്ട് ആയിക്കൊണ്ടിരിക്കും. ഇത് എത്രത്തോളം ആ ബോണ്ട് കാർബൺ കാർബൺ ഡബിൾ ബോണ്ട് എത്രത്തോളം ഫോം ചെയ്യുന്നോ അത്രത്തോളം CBr ബോണ്ട് വിൽ ബി weakened. Okay, so in this transition state എന്ത് ചെയ്യുന്നു, there is a flow of electrons അല്ലെ, നമ്മൾ കാണാം ഒരു ഫ്ലോ ഓഫ് ഇലക്ട്രോൺസ് ആൻഡ് ബോണ്ടിന്റെ ഷിഫ്റ്റ് കാണാം, ബോണ്ട് ഷിഫ്റ്റ് കാണാം. ഓക്കെ, അപ്പോൾ എന്ത് ചെയ്യുന്നു, ഫൈനൽ പ്രോഡക്റ്റിൽ എന്താ പറ്റുന്നത്, From this carbon, ഒരു hydrogen remove ചെയ്തു, and that bond has shifted to this one. Carbon-carbon double bond. പുതിയൊരു carbon-carbon double bond ഉണ്ടായി, and Br is eliminated from this carbon. Okay, and water and Br minus are the elimination products, side products. Okay, this is the mechanism. The reaction proceeds through a transition state in which electron flow takes place. Okay, or step by step item in അങ്ങോട്ടും ഇങ്ങോട്ട് connected ആയിട്ട് ഒരു flow of electrons is taking place. Okay, orientation and reactivity is governed by Zaitsev rule itself. Now let's check. Okay, ഇത് 2-bromobutane ആണ് നമ്മൾ എടുത്തിട്ടുള്ളത് substrate ആയിട്ട്. അപ്പോൾ when treated with alcoholic KOH, എന്ത് ചെയ്യുന്നു? 2 butene and 1 butene are the possible products. നമ്മൾ പറഞ്ഞു, since this is more substituted, this is the major product. Okay, 1 butene minor ആയിരിക്കും. ഇനി എങ്ങനെയാണ് E2 മെക്കാനിസത്തിലേക്കൂടെ E2 butene ഉണ്ടാവുന്നതെന്നാണ് നമുക്ക് ചെക്ക് ചെയ്യേണ്ടത്. അപ്പോൾ ഇവിടെ നോക്കുക, ഇവിടെ OH minus ഉണ്ട്. OH minus എന്ത് ചെയ്യുന്നു? It forms, it attacks, നമ്മൾ Br, കാർബൺ, ഈ Br-ഉം ഈ കാർബൺ ഒരു ഹൈഡ്രജനുമാണ് പോകേണ്ടത്. സോ ഈ ഹൈഡ്രജൻ എടുക്കാം, ഈ OH എന്ത് ചെയ്യുന്നു? ഈ ഹൈഡ്രജനിലേക്ക് അറ്റാക്ക് ചെയ്യുന്നു. ഈ ഹൈഡ്രജൻ OH എടുക്കും. അപ്പോൾ എന്ത് ചെയ്യുന്നു? ഈ ബോണ്ടില്ലേ, ഈ CH ബോണ്ട് എന്ത് ചെയ്യുന്നു? അതിന് അവിടെ ആവശ്യമില്ല. That will be shifted towards this carbon-carbon single ബോണ്ടിലേക്ക് ഷിഫ്റ്റ് ചെയ്യും. ആസ് എ റിസൾട്ട് എന്താണ്? ഈ കാർബൺ ഓൾറെഡി 4 ആണ്, ഇത് 5ാമത്തെ ബോണ്ട് വരുന്നു. സോ ആരെ പുറത്താക്കും? Br will be expelled. And in the transition state, എന്ത് ചെയ്യുന്നു? OH-ഉം H-ഉം തമ്മിലുള്ള ബോണ്ട് എത്രത്തോളം ഉണ്ടാവുന്നോ അത്രത്തോളം H-ഉം കാർബണും തമ്മിലുള്ള ബോണ്ട് will be weakened. ഇത് എത്രത്തോളം വീക്ക് ആവുന്നോ അത്രത്തോളം ഈ കാർബൺ-കാർബൺ ഡബിൾ ബോണ്ട് ഫോം ചെയ്യും. ഈ കാർബൺ-കാർബൺ ഡബിൾ ബോണ്ട് എത്രത്തോളം ഫോം ചെയ്യുന്നോ അത്രത്തോളം കാർബൺ Br ബോണ്ട് എന്ത് ചെയ്യും? വീക്ക് ആവും. Okay, and you'll be getting 2 butene as the major product. And 1 butene വളരെ കുറച്ചേ ഉണ്ടാവുള്ളൂ എന്ന് പറഞ്ഞു. ആ 1 butene കിട്ടണമെങ്കിൽ ചെയ്യേണ്ടത് ഇതാണ്. ഈ CH3 ഇല്ലേ, ഈ CH3 എന്നുള്ള ഹൈഡ്രജൻ എടുത്താലാണ് എന്ത് കിട്ടുക? 1 butene കിട്ടുക. ഓക്കെ, ആൻഡ് ഇതെന്തുകൊണ്ടാണ് ഇത് വരുന്നതെന്ന് വെച്ചാൽ ഇതിന്റെ ട്രാൻസിഷൻ സ്റ്റേറ്റ് വരച്ചാൽ 1 butene കിട്ടുന്ന ട്രാൻസിഷൻ സ്റ്റേറ്റ് വരച്ചു നോക്കിയാൽ we can see that this is the more stable transition state. Okay, more stable transition state is for എന്താണ്? 2 butene ആണ്. That's why it is formed more easily. 2 butene ആണ് ഏറ്റവും അധികം ഉണ്ടാവുക. Okay, 81% 2 butene ആണ് കിട്ടുന്നത്. Now E1 mechanism. It's just like the SN1 mechanism എന്ന് പറയാം. Okay, it's a unimolecular elimination reaction. Okay, the rate is proportional to the concentration of substrate alone. Substrate ന്റെ concentration മാത്രം ഡിപെൻഡ് ചെയ്യുന്നു. It is not depending upon the substrate concentration of the base. Okay, നമ്മൾ ബേസ് എടുക്കുന്നുണ്ട്, ആ ബേസിന് ഡിപെൻഡ് ചെയ്യുന്നില്ല. K is the rate. Okay, പിന്നെ എക്സാമ്പിൾ എന്ന് പറയുന്നത് tertiary halides. All tertiary halides normally എങ്ങനെയാണ് undergo elimination reaction by E1 mechanism. അവർ അതിനാണ് പ്രിഫർ ചെയ്യുക. ഓക്കെ, അതെന്തുകൊണ്ടാന്ന് വെച്ചാൽ നമ്മുടെ മെക്കാനിസത്തിൽ അതിന്റെ ആൻസർ ഉണ്ട്, അതൊക്കെ പറയാം. ഇതാണ് മെക്കാനിസം എന്ന് പറയുന്നത്. മെക്കാനിസത്തിലെ ഫസ്റ്റ് സ്റ്റെപ്പ്, ദി സ്ലോ സ്റ്റെപ്പ്, ആൻഡ് സ്ലോ സ്റ്റെപ്പ് ഇസ് ദി റേറ്റ് ഡിറ്റർമിനിങ് സ്റ്റെപ്പ് അല്ലെ. അപ്പൊ എന്ത് ചെയ്യുന്നു? a carbocation is formed. Okay, a carbocation is formed and എന്ത് ചെയ്യുന്നു? ഈ കാർബോകാറ്റോണിലേക്ക് ആര് ആഡ് ചെയ്യുന്നു? ആ പ്ലസിലേക്കല്ല OH വരുന്നത്, അപ്പൊ അത് സബ്സ്റ്റിറ്റ്യൂഷൻ ആണ് നമുക്ക് കിട്ടുക. അപ്പോൾ എന്ത് ചെയ്യുന്നു? വരുന്ന ബേസ് എന്ത് ചെയ്യുന്നു? അതിന് തൊട്ടടുത്തുള്ള ഹൈഡ്രജൻ എടുക്കുന്നു, അപ്പോൾ കാർബൺ കാർബൺ ഡബിൾ ബോണ്ട് ആയിട്ട് മാറുന്നു. അപ്പൊ നിങ്ങൾക്ക് വരേണ്ട ഒരു ഡൗട്ട് എന്താണെന്ന് വെച്ചാൽ നമ്മൾ OH മൈനസ് എടുക്കുന്നു അല്ലെങ്കിൽ വാട്ടർ എടുക്കുന്നു എന്ന് പറഞ്ഞു. അപ്പോൾ സബ്സ്റ്റിറ്റ്യൂഷന്റെ കേസിലും ആൽക്കൈൽ ഹാലൈഡും വാട്ടറും കൊണ്ട് ട്രീറ്റ് ചെയ്തിട്ട് നിങ്ങൾക്ക് ആൽക്കഹോൾ ആണ് കിട്ടിയത്. പക്ഷെ ഇവിടെ ശ്രദ്ധിക്കണം, ആൽക്കഹോളിക് KOH നമ്മൾ പറയുന്നുണ്ട്. അപ്പോൾ സ്ട്രോങ് ബേസ് എടുത്താലാണ് ആ സബ്സ്ട്രേറ്റിന് എന്ത് നടക്കാം? എലിമിനേഷൻ റിയാക്ഷൻ നടത്തുന്ന ടെൻഡൻസി കൂടുക. ബേസ് മൈൽഡ് ആണെങ്കിൽ സബ്സ്റ്റിറ്റ്യൂഷന്റെ പോസിബിലിറ്റി ആയിരിക്കും കൂടുക. ഓക്കെ, അതൊന്ന് ശ്രദ്ധിക്കാം. പിന്നെ ഞാൻ പറഞ്ഞു ടെർഷ്യറി ആൽക്കൈൽ ഹാലൈഡ് gives predominantly എന്താണ്? they undergo elimination by SN1. അതിന്റെ റീസൺ എന്താ? ഇപ്പൊ നമ്മൾ കണ്ടു കാർബോകാറ്റയോൺ ആണ് ഇന്റർമീഡിയറ്റ് ഇസ് കാർബോകാറ്റയോൺ. ആൻഡ് നമ്മൾ ഓർഡർ ഓഫ് സ്റ്റെബിലിറ്റി ഓഫ് കാർബോകാറ്റയോൺ നോക്കിയാൽ നമുക്കറിയാം എന്താ? ടെർഷ്യറി, സെക്കൻഡറി, പ്രൈമറി എന്നാണ്. അപ്പോൾ ടെർഷ്യറി ആൽക്കൈൽ ഹാലൈഡ് വിൽ ഗിവ് യു tertiary carbocation, secondary alkyl halide will give you secondary carbocation, and primary alkyl halide will give you primary carbocation. And primary carbocation is least stable, അതുകൊണ്ട് തന്നെ it will not undergo elimination by SN1 mechanism. Primary alkyl halides will give elimination product only by E2 mechanism, not by E1 mechanism. And since tertiary carbocation is the most stable species, all tertiary alkyl halides will undergo elimination by E1 mechanism. Secondary in the case, it depends on the other factors like the base, the solvent, concentration, temperature, etc. അതൊക്കെ വെച്ചിട്ടാണ് secondary തീരുമാനം എടുക്കുക whether to go for E1 or E2. Okay. And just like E2 mechanism, the orientation and reactivity of alkyl halides in E1 mechanism is also governed by Zaitsev law. Here that is illustrated by the example of 2-chloro 2-methyl butane, and when this is reacted with water, you will be getting 2-methyl 2-butene. Here the structure is little, okay, this is not there. So this is CH3 CH double bond C CH3 CH3. This is 2-methyl 2-butene and this is 2-methyl 1-butene. Okay, here according to Zaitsev rule, the substitution should be greater. Okay, നോക്കാം അത് ശരിയാണോന്ന്. ഇവിടെ 1, 2 and 3 alkyl substitutions are there in the case of 2-methyl 2-butene, and if we check with this one, there are only 2 alkyl groups. Here both are hydrogens, so 2-methyl 2-butene is the major product. And now we have to explain by E1 mechanism the formation of 2-methyl 2-butene as the major product. Here the first step is the formation of the carbocation, right? So this is the carbocations formed, and the base water, അല്ലെങ്കിൽ നമുക്ക് from here, from water we can say that OH minus is coming. Okay, that's one of the same. And if the OH minus base is coming, അല്ലെങ്കിൽ water ആണ് base എങ്കിൽ അത് വന്നാലും, it has two options to abstract hydrogen, either from this side, this red one, or this purple one, right? And according to the mechanism, for the double bond to be formed here, the base abstracts this hydrogen and product is formed like this. Okay, product is formed like this, and this is the major product. For this molecule, for this product to be obtained, the base would have attacked at this carbon atom and you will be getting this product. Okay, so the why this is formed, that we have explained. As the number of hyperconjugative structures increases, the stability also increases. This is the explanation of E1 and E2 mechanisms. And now we have to see what you mean by the dehydration of alcohols. Dehydration of alcohol means from an alcohol, water molecule is eliminated from adjacent carbon atoms. Okay, H and OH, water molecule is eliminated from adjacent carbon atoms from an alcohol to give you an alkene plus water. Okay, these are the examples. From ethanol, let's begin from the primary alcohol. From ethanol, here only 2 carbon atoms are there, so OH is eliminated from 1 carbon and 1 hydrogen is eliminated from the second carbon to give ethylene. In the case of 2-propanol, 1, 2 and 3 carbon atoms are present. The hydrogen is eliminated from, OH is eliminated from the second carbon and hydrogen is eliminated from any of the methyl groups. Here also this is identical one, so there is no scope for confusion because both are methyl groups, so you'll be getting only one product, that is propene. And in the case of tertiary butyl alcohol, 1, 2, 3, there are 4 carbon atoms and 1 OH is removed from the second carbon atom and 1 hydrogen is removed from any of the 3 alkyl groups. Here also all the other alkyl groups are similar, so you'll be getting only one product. But if the same reaction, if you want to perform this dehydration from a compound like this, 2 CH3 CH2 CHOH CH3, here 2 possibilities are there. Here the elimination is driven by Zaitsev rule. Okay. And regarding the mechanism, primary alcohols undergo dehydration by E2 mechanism, whereas secondary and tertiary alcohols undergo elimination by E1 mechanism. First, let's check the simplest one, which is the elimination of primary alcohols. Okay, so the catalyst is sulfuric acid, concentrated sulfuric acid. It provides H plus and HSO4 minus. First, it is dissociated like this, and this alcohol is protonated. This species is the protonated alcohol. Okay, in all the dehydration reactions of all alcohols, this is the first step. Okay, alcohol is getting protonated, and then this HSO4 minus, which is remaining here, this HSO4 minus attacks the hydrogen from the neighboring carbon atom, so that this bond is shifted to the carbon-carbon single bond, shifted in between carbon-carbon single bond, and as a result, this species is eliminated as water. Okay, OH2 plus is eliminated as water, and H2SO4 is a catalyst, so it is regained. Okay, or reaction take part either this adepole varunala catalyst. So we have retrieved our catalyst so that it can be used in the elimination of another ethanol molecule, and our main product is ethylene. Okay, and see, if we are conducting this elimination reaction, it's an example of this is isopropyl alcohol. It is a secondary alcohol. Okay, both secondary and tertiary alcohols undergo elimination by E1 mechanism. I am depicting this one with a secondary alcohol here. This is isopropyl alcohol, and it is converted to propene. Okay, the first step is the same, dissociation of sulfuric acid to H plus and HSO4 minus, and protonation of alcohol takes place. Just in the case of ethanol also we have seen this, and from here the mechanism getting changed. Here it is proceeding through carbocation intermediate, and therefore CH3 CH3 plus is obtained, and this HSO4 minus is attacking the neighboring hydrogen. Okay, attacking the hydrogen of the neighboring carbon atom, so that the double bond is formed like this. Okay, in the same way, tertiary butyl alcohol also gives you the product. Okay, with this, I am winding up the discussion about elimination reactions. Thanks for watching.